All right, so we might ask ourselves, well, how did this law of sines come about? After all, we haven't got any right triangles going on. What makes us think that this is the case? Well, let's look at the situation right here. Let's say that for argument's sake, I know what angle A is. I know what the length of side B is, and I know what the length of side A is. So we've got a side-side angle situation. How do I really know that I'm getting the right information right here? Well, let's concentrate on this fact right here. If I were to draw a perpendicular from vertex C down to the base of the triangle, which is along side C, what could I tell? Well, if I knew what angle A was, I could tell you right now that the sine of angle A, whatever it is equal to the length of the opposite side over the hypotenuse, and we just built a right triangle right here in which the opposite side is that altitude h divided by the length of side B. And so if I was interested in finding the length of that altitude, I would find that taking side B and multiplying it by the sine of the angle A would be equal to the length of side H. Well, that's kind of useful. Um, but that still doesn't quite get it to me, right? I mean, what if I still am interested in angle B right here? Well, let's take a look at that situation. We know that angle B, if we have its opposite side B, and we knew something, and we have this side A and we have this altitude right here, we could tell you that the sine of the angle B is equal to the length of its opposite side. So this right triangle right here has an opposite side of, you guessed it, altitude h, divided by the length of side A, which is right here, that's its hypotenuse. And so the side A, when it's multiplied by the sine of the angle B, will also give us that altitude. So what does this tell us? Well, it's the same altitude for both of them. These guys are equal, right? It's the same altitude, it's the same triangle. Therefore, if we take B, multiply it by the sine of A, that will be equal to A multiplied by the sine of B. Well, that's kind of cool because look at what happens. If I were to divide both sides by A and then by B, I would be able to rewrite this expression and I would find that the sine of angle A divided by side A is equal to the sine of angle B divided by its opposite side length B is true. And, well, there we go. That is the law of sines. Now, if we used the same perspective, we could say the same thing about sine of A. Sine of A, boy, that's a funny way to spell it. Sine of angle A divided by opposite side A would be the same as the sine of angle C divided by its opposite side C. Or we might find that the sine of angle B divided by its opposite side B would be equal to the sine of C divided by its opposite side C. Or we could do all kinds of funky things right here, but essentially when we combine these all together, we simply write a three-way equation to represent that the sine of angle A divided by its opposite side A is equal to the sine of angle B divided by its opposite side B is equal to the sine of angle C divided by the length of its opposite side C, which in words says says in words that the sine of any angle divided by the length of its opposite side is always equal to the sine of any other angle divided by the length of its opposite side.